swap space, which we'll look at momentarily. So now we've got two. We could go ahead and create a mirrored RAID set. That would certainly work. However, our intent is to create a RAID-5 set, which is striping with parity, which offers performance enhancements plus greater size allocation. So we lose less storage when we allocate using RAID-5 as opposed to RAID-1, or striping with parity as opposed to mirroring. Let's go ahead and click on RAID again. Notice we now have the ability to create a RAID device because we currently have two software RAID partitions. However, we want a third. So we'll go ahead and click on Create a Software RAID Partition, then OK. And we'll make it out of SDC by deselecting SDA and B and setting its size to 20,000 megabytes. Again, there are options to fill space up to a certain size, allowing the partition to grow, or fill to the maximum allowable size. But be careful when using those options when multiple partitions are configured similarly, because they'll compete for the remaining space on the disk. This doesn't need to be a primary partition. And now we've got three software RAID partitions plus free space. So to create that RAID device, which will be beneath or created beneath the dev tree as MD0 or beginning with MD0, click on RAID once more, and the second option is auto-selected, create a RAID device. The default device again will be created beneath the dev tree. The dev tree is a special directory within Linux and Unix systems used to house drivers or modules, means of accessing hardware devices connected to your Linux system. We'll click on OK. And here's another option, by the way, clone a drive to create a RAID device. You can actually clone an existing drive to create a device. So if there's already a RAID set up on a drive that you'd like to clone or duplicate to another drive, for example, we've got 3 disks, SDA, B, and C. If we've set up SDA and we'd like SD, B, and C to follow, then just simply select clone a drive, select the source drive, the target drive, and the partition table will be duplicated to the target drive, so that you don't have to repeat the steps of inserting the number of megabytes and whether or not it should be global and so on and so forth. So we'll create a RAID device, and the mount point for this RAID device will be the root file system. However, there are other mount points, the common mount points, opt, back through boot, but boot we've already allocated. We'll create this 20 gigabyte space for root, and its file system can be any of the following: ext3, physical volume to then be assigned to logical volume management, ext2, swap, vfat. The RAID device will be MD0, however, you can select any other number. It defaults to MD0, that's the first device. The RAID level needs to be indicated. Here are the supported types: 0, 1, 5, and 6. With the common ones being 0, 1, and 5. RAID 0 offers no redundancy, but it does offer fast access to disks. It's a way of creating volume sets, for those of you familiar with volume sets from Solaris or from Windows NT 2000, 2003, etc. So RAID 0 is analogous or similar to volume sets in other operating systems, where it allows you to aggregate storage and present that storage as one large unit or one aggregate, consequently writing the data sequentially to the disks that are part of the volume set. However, if one of the disks in the set fails, you lose your data. So use RAID 0 when you need speed and the data is not as important, perhaps you back it up often. RAID 1 is mirroring. RAID 1 requires 2 identical partitions, or 2 identical disk sizes. It's used to copy data from one to the other or to perform multiple writes. So when you issue a write, let's say you've saved a text file, the text file gets written to both disks. And in the event of failure of one of the disks, let's say disk 1 fails of the two disk set, disk 2 will maintain a copy and be accessible unbeknownst to the user. So this is truly a redundant way of doing business. RAID-5 is in between RAID 0 and RAID 1 in that it provides fast access but also provides redundancy up to 1 disk failure. So in a RAID-5 set, if you've got at least 3 disks, which is a requirement, if one fails, your system will operate in a degraded fashion, but your data will still be available, and your performance will be restored once you've replaced the failed disk and the RAID process has rebuilt the parity information. But with Raid-5, the data is striped across all 3 disks, or at least 3 disks, striped across all the disks in the set, and parity information is maintained. In the event that one disk fails, the RAID set will still be able to service your clients, albeit in a degraded fashion. So Raid-5 offers the best of RAID 0 and RAID 1 without sacrificing too much storage or too much performance. We'll go ahead and select RAID-5. These are the partitions, and they are physical disks indicated by the alpha values A, B, and C that will be used. SDA2, the second partition, SDB1, SDC1. And you can also assign spares. So if we had another partition, another software RAID partition, we could include it and assign it as a spare. In the event that one of the disks fails, the spare will be used to immediately rebuild the parity information so that performance isn't degraded for too long a time. Let's click on OK. And this will create momentarily our software RAID device located at dev MD0, and that's where the root file system will be mounted. Here we see RAID devices, a new container which is expanded, which contains dev MD0. The file system which will be overlaid is ext3, and notice the size is 40 gigabytes. Again, with Raid-5, you lose the storage of one component, not half the storage as you do in the case of Raid 1. So in this case, we benefit because we get more of the storage. So we've allocated 60 gigs, we've only lost 20. And below, we still have extra storage to create additional partitions. So if we scroll down, we'll see that on SDA, we've got boot, software RAID, and free space. Now, it's a good idea to store your swap on a different drive to increase performance. In other words, to allow your system to initiate I/O to as many distinct disks as possible. So with that said, we can use either SDB or SDC to store our swap. So if we navigate to SDB and create a new partition, you always need swap. Whether or not your OS uses it is a separate issue. We ignore the mount point section as we've done in the text-based installation, navigate to swap, which voids this section, deselect the disks that are not to be included or are not candidates, and since this system has half a gig of memory, we'll make swap 1024 megabytes or a gigabyte. Doesn't need to be a primary partition, and now we've got swap allocated on SDB2, and when the system comes up, it'll have at least a gigabyte worth of swap. If you wanted to create more swap, let's say another gigabyte on SDBC, or SDC that is, as SDC2, then go ahead again and indicate type swap, deselect the drives that should not be candidates, and set the size to something that makes sense. It doesn't have to be identical to the other swap partition. But in this case, just to make it simple, we'll make it the same. So now we've got 2 swap partitions for a total of 2048 megabytes, or 2 gigabytes of swap, and we still have free space. So we've got a RAID device, MD0. We can create additional RAID devices, because if you notice in the top section, the graphical layout tells us what storage is available to us, how the storage is being used per disk. Each disk is 36 gigabytes, but we're using roughly 60% of each disk with free space to spare. So if we wanted to make boot, for example, RAID, or to install it on a RAID partition, we could create 2 new software RAID partitions, mirror them, and then mount boot to those 2 partitions. And it would create a new device, dev MD1, for example, instead of dev MD0. But it's not necessary. So dev MD0 will serve as our root container. Boot will be on dev SDA1, and it will not be redundant. SDA2 is swap. SDB1 is software RAID. SDB2 is swap. And SDC1 is RAID. SDC2 is swap, with free space to spare. Now, after you've created your software RAID device, such as dev MD0, you have the ability still to include this device in logical volume management. So we could create a logical volume out of 1 or more RAIDed devices. It's entirely up to you, which would create an additional layer of abstraction. So the kernel would take care of rating or striping the data across the 3 disks, and then the kernel will also take care of the logical volume management, the management of the storage in a dynamic fashion such that we can grow, decrease, and so on the logical volumes. Once your storage is set and you're ready to move on, click on Next. Again, we've allocated 40 gigabytes Raid-5, or 16 gigabytes, which renders 40 gigabytes Raid-5, which is more than enough storage for all of our mount points, so we don't need a distinct mount point. So when you're done, click on Next. It tells us the Grub bootloader will be installed on DevSDA, which is the first hard drive, and the bootable partition, DevMD0, will be set. This will be the default partition. If we'd like to assign a bootloader password, now's our time to indicate as such to prevent unauthorized access. We'll click on OK. If you need advanced bootloader options, such as parameters to pass into the bootloader, by clicking on Check, another form will be made available. And here we have the ability to assign the IP address dynamically, statically. We'll leave it at dynamic for now because we'll be reinstalling the server. The server name, instead of Deb1, let's set it to be Linux CBT Serv2. This is the second server. And again, DHCP will take care of the default gateway, the primary DNS, and the secondary DNS. In our prior installation, we saw that when we assigned the address statically, it forced us to specify the gateway DNS, primary and secondary DNSs manually. With DHCP for IPv4 and v6, everything's grayed out, as those settings will be downloaded from the server. Now let's continue with the fully qualified name. We left out the domain part, and we'll click on Next, and this will take us to the time zone information. The system clock does not use UTC, and it tells you when you hover over it the purpose. This is another reason for using the graphical environment. If you want to be able to switch between normal and daylight savings time, then set your system clock to use UTC and allow the operating system to modify it accordingly. Let's set a password for administrator and proceed with the installation. We'll click on Next, and this will retrieve installation information. We'll ignore these groups because again we'll be reinstalling the system momentarily. Again, our intent